All right, let's talk about the incredible machine you live in. Every single move you make, from a tiny twitch to a giant leap, is all thanks to this amazing internal system. So today, we're going to put your knowledge of your own musculoskeletal system to the test with a little quick fire pop quiz. You ready? Let's get started. But really, how well do you actually know this machine? I mean, do you know what's cushioning your knees when you jump? Or what kind of joint lets you wave your arm around like that? Well, it is time to find out. Okay, let's do this. And hey, no pressure. This isn't some high-stakes exam. It's just a fun way for us to peek under the hood, you know? First up, we're going to look at a really important part of your leg, something that acts like a shock absorber. Think about it. Every time you run or jump or even just walk down the street, there are these little structures in your knees just working away, taking all that impact. So what exactly are they, and what's their main job? Okay, question number 1. What is the primary function of the menisci in your knee? Is it A, to give you more range of motion, B, to provide stability, C, to produce that joint fluid, D, to cushion the joints and distribute weight, or E, to actually produce cartilage? Go ahead, take a guess. And if you said D, you nailed it. The menisci are basically your knee's personal shock absorbers. They're like these perfect little cushions that spread out all the force. Now, what's really interesting is that, yeah, they do help with stability, but that's more of a side gig. Their main job is cushioning. And see that option C about synovial fluid? That's a totally different part, the synovial membrane. Think of that as the built-in oil can for your joints. All right, nice work. So we've covered a key function. Now, let's talk about form. Time to get down to the bare bones. Literally. Let's see if you can ID a specific bone. So picture a skeleton. Which one of these bones do you find in the forearm? Is it the scapula, the radius, the fibula, the sternum, or the clavicle? The answer is B, the radius. That's the one. It's the bone in your forearm that's on the same side as your thumb. Here's a cool way to remember it. When you turn a doorknob, that twisting motion, that's your radius rotating around the other forearm bone, the ulna. Pretty neat, right? The other options, well, they're all over the place. Your shoulder blade, your lower leg, your chest, but not your forearm. Okay, so we've ID'd a bone, but let's be real. The real magic isn't just the bones themselves, it's how they move. That brings us to our third question, all about joints. You've got joints that bend, joints that pivot, but which kind gives us the absolute most freedom of movement? So, which one is it? Which type of joint allows for the greatest range of motion? Just think about bending your elbow versus swinging your whole arm around. Which of these 5 is the true champion of movement? And the winner is B, the ball and socket joint. Yep, this incredible design is the secret behind our most powerful and flexible movements. I mean, the name says it all, right? You've got a ball-shaped end of one bone that fits perfectly into a little cup-like socket of another. It's such a simple but brilliant design, and it's what lets your shoulders and hips move in basically any direction you want. Up, down, side to side, all the way around. It's why you can throw a ball and not just, flap your arm up and down. And this is a perfect way to visualize it. Your elbow? That's a hinge joint. It works just like a door hinge. It only swings open and closed. But the shoulder, that's a ball and socket. It's more like a joystick on a video game controller, giving you total freedom to move around. It's amazing engineering built right in. Okay, so we've looked at the big picture of how we move. But what about the building blocks? What makes our bones so unbelievably strong in the first place? For this next one, we're going to have to zoom way in, down to the microscopic level. All right, this one's a little more technical, so put your thinking caps on. We're talking about the bone matrix. That's basically the framework that gives a bone its actual structure. So which of these proteins is the main ingredient? Is it elastin, collagen, actin, keratin, or myosin? And the answer is B, collagen. You can really think of collagen as the unsung superhero of your skeleton. It creates this tough, fibrous web that gives bones this amazing 1-2 punch of strength and flexibility. That's why they can take a hit without just shattering. And as you can see, those other options are all important proteins for sure, but they have different jobs, like making your muscles work or building your hair and nails. We are here. The final question. We've talked about cushions, we've identified bones, we've looked at motion. But there's one more piece to the puzzle. What keeps everything moving smoothly? What stops all those parts from grinding together? It's all about lubrication. So let's get right to it. Which structure in a joint is the little factory that produces synovial fluid, that essential stuff that keeps everything lubricated? This is it, your last chance to guess. And the final answer is B, the synovial membrane. That's the one. It's this special lining inside our joints that's responsible for making that all-important fluid. It's really easy to mix up all these different parts, but this lays it out so clearly. Cartilage is the smooth cap on the bones. Ligaments connect bone to bone, and tendons connect muscle to bone. Each one has its own specific and super important job. So let's just pull all of this together for a second. It doesn't matter if you got every question right or if this was all new to you. The main thing is seeing how all these pieces work together in perfect harmony. It's really a four-step dance. You've got the structure from the bones, the lubrication from the synovial fluid, the connections from ligaments and tendons, and it all comes together to create smooth, pain-free movement. It's like a perfectly conducted orchestra inside your body. We've really only just scratched the surface today. This body you live in is an absolute masterpiece of engineering. So the real question is, now that you've had a little peek at how beautifully it all works together, what part are you curious about next?